Hello, my name is Sagar Shukla, and this is my video for my final project submission. I will be doing this as an individual project, creating a local database. My topic is looking into historical stock price performance and building queries and manipulating data set based off that. This touches on my own individual background, capital markets. So I will be presenting the overview of what I created. I used SQLite Jupyter Notebook in Google Colab, and I also have a presentation slide deck to go through the methodology. So starting with the overall coding, as I mentioned, the biggest API I used was the Yahoo Finance API to extract historical price index pricing between certain date range as specified by the user. And then I create visualizations using Matplotlib and Seaborn and Pandas. Um, so overall, the code allows user-driven input to specify dates. I create tables as per query instruction in creating the database. I utilize three main indexes, which is the S&P 500, the NASDAQ, and the Dow Jones. Calculate return, and then I have my CRUD operation, which um, includes read, update, and delete. Read being getting the top five closing prices per index, modifying the closing value, and updating the close value for price entry. And then I have three different visualizations. The first being index price trends between the specified date range. The second being total trading volume by index for each of the indexes, again, based on the date range specified. And then finally, volatility comparison by index. I also look into annual return percentage per index in more of a tabular format for the three indexes, and you can see each year's annual return in percentage based on the date specified by the user. So overall, as mentioned, this is a historical analytics database project. Um, I look into in terms of tools and technologies, I use Python for scripting and data handling, SQLite for the creating the local database, Y Finance, which is the Yahoo Finance API, is the best source for public index pricing data, which I use to source the historical pricing. Pandas, Matplots, Seaborn for manipulation, visualization, and all of this was done on Jupyter Notebook. With in terms of core functionalities, I create and populate a stock index database for stock price for index pricing and historical returns. I implement the CRUD operations, calculate return percentage, volatility, and Sharpe ratio, which are basically financial metrics that help you understand and look into financial data and understand performance and use that as a basis of investment strategies. Um, as per my visualization, I generate some charts and tables. And I also allow for a user-defined range, as you can see within the code there. Um, I try to limit it. So if you select outside of the 15 day, year range, it will give you an error. The range is specified between 2009 and 2024. And this was just because utilizing more historical data from Y Finance when trying to extract it makes the program a little bit clunky and makes data querying a bit more harder to process just for efficiency purposes. The user-defined time range has been restricted to those 15 years. Then in terms of my CRUD operations, as mentioned, I use read, update, and delete, um, along with obviously creating the database. So what read does is it gets the top five closing prices for a selected index. In this example, I use NASDAQ specifically. So what it does is based on the index we selected, it will look and within the data set range and historical price range that we have, it will extract and select for the top five closing prices. Just for context, indexes do have opening and closing day prices, which are marked. And usually closing day prices are what is recorded more often to look at price performance and just historical metrics. So then it just generates those five and provides it. For my query for updating, I chose to modify a closing value. So based on the data set, in this example, the first entry, I add 10 to the price of it and reset it just to be able to use that as a value. So again, the query finds the first entry within the data set, adds 10 to it, and then prints it out. And finally, for my last query there, delete, I chose to specify that as removing a specific row. So in this example, if I were to use the S&P 500, the last price data that I would have for the S&P 500, the query finds it, selects for it, and then deletes it out of the data set. Analysis and insights, as I mentioned, these are the three charts I created, index price trends, total trading volume by index, and volatility comparison. Um, just for overall index purposes and index historical pricing, these metrics are usually what financial analysts use to be able to determine um, best practice and really drive insights into how index performance is, what kind of investment strategy they should use. So particularly for this example, we can see just looking at price returns, the Dow Jones historically has done better than some of the other indexes, but it is also more volatile. And it also has liquidity issues, being that its trading volume is much lower than the other two indexes. So these were just some of the insights you can derive from these charts. Challenges I faced, obviously, schema planning, just understanding which metrics to use, how I want to plan it, how I want the database to look, the data set limitations of Y finance, as I mentioned, for the 20-year range, and making sure I safeguard the input, converting the insights and understanding what kind of visualizations I wanted to present to really drive insights and make it easier for the average person or retail investor or even just a student to look at the overall data and understand how they would be able to manipulate it and applying the capital markets knowledge. For future improvement, what I would love to do is incorporate other international indexes like the Nikkei and the Hang Seng. This would require setting a specific currency, which is the most difficult challenge, is making sure I have a foreign exchange currency converter so I can set everything to the same currency. That way, all the metrics that I'm calculating are directly comparable, and we can derive insights from them. Thank you. That is my presentation.